Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are going to discuss about the chapter Introduction to Atom. About this chapter, in the earlier sessions we discussed about the atom and the Dalton's atomic theory and the discovery of electrons. We have seen these all. Now we are going to see about discovery of protons in this session. Okay? So after the discovery of electrons, it was realized that there must be positive charged particles within the atom to balance the negative electrons and create electrically neutral atoms. So in the earlier concepts, they believed that atoms are electrically neutral. And later, they have discovered these electrons present inside the atom. We know electrons are having negative charge, isn't it? So, as there are negatively charged particles inside the atom, there must be some positively charged particles also to inside the atom to counterbalance the negative charge of these electrons, and hence the atoms will be neutral electrically. So, to maintain the electrical neutrality inside the atom, along with the electrons, there must be some other particles with a certain positive charge. Okay. In this way, they have realized that there must be certain positive charged particles inside the atom. So in 1886, again Goldstein, while working with the cathode ray tubes, found that in addition to the electrons that travel from the negatively charged plate, that is from the cathode, there were some other rays also that moved in the opposite direction, that is from anode side to cathode side, isn't it? In the discharge tube experiment, J. Thomson, he found that certain particles are moving from cathode side to anode side. He named them as cathode ray particles and later they were called as electrons. With the same experiment, again Goldstein found some other particles which are moving in the opposite direction to that of cathode ray particles. Means he found some other particles which are moving from anode side to cathode side. Later, they called these particles as anode rays, which are also called as canal rays. So these rays moved through perforations made in the cathode to the positively charged plate, which is the anode. Means from the anode side, these particles are moving towards the cathode and they are moving through the perforations made on the cathode and they are making some scintillations at the back side of this cathode, which is on the screen. Some red glow was observed. They call these particles moving from anode side to cathode side as anode rays or canal rays. This proved that these rays containing particles which are positively charged, because here they are moving towards the negatively charged electrode. So this proves that these particles are positively charged. These positively charged particles were called anode rays or canal rays because they are moving from the side of anode to the side of cathode. So they are called anode rays. In the earlier case, electrons were moving from cathode side to anode side. That's why they were called cathode rays. So here these rays which were discovered by Goldstein are moving in the opposite direction to that of cathode rays. That means they are moving from the side of anode to cathode and they are making certain red glow scintillations on the screen kept backside to this cathode. That is why these rays are called as anode rays, which are also called as canal rays. Now let us see the how these positive rays are formed, how these anode rays are formed. When high electrical voltage is applied to a gas, its atoms break up into negatively charged particles and positively charged particles. Isn't it? This happened in the case of discovery of cathode rays also. High voltage current is applied on a gas at very low pressure. Then the gaseous molecules split up into positively charged particles and negatively charged particles. There, the negatively charged particles were proved as electrons. So along with the electrons, certain positively charged particles are also emitted from the gas molecules. These positively charged particles formed by the removal of electrons from the gas atoms are called as positive rays or canal rays or anode rays also. For example, if you take hydrogen gas in the discharge tube at a very low pressure, then if high voltage current is applied on this gas, there the molecules of hydrogen first split into respective atoms, hydrogen atoms. Each hydrogen atom will be separated into electron and one positive particle. These positive particles produced here are called anode rays. Okay, so when gas is applied with high voltage current, that splits into negative charged particles and positive charged particles. Here the negative charged particles produced are called cathode rays, which we are calling now as electrons. The name electron was given by G.J. Stoney for this, as we know. Okay, these cathode rays are called electrons. So along with the negative charged particles, certain positively charged particles are also produced. These positive charged particles produced from the gases are known as anode rays or positive rays, which are also called as canal rays. Okay, out of these all kinds of positive charged particles, the smallest particles produced are called as protons. So because here, depending upon the gas taken in the discharge tube, the positive charged particles will be differed. If we take hydrogen gas, the positive charged particles are H plus ions. Instead of taking hydrogen, if we take helium, what happens? On applying high voltage current on this, these helium atoms will split into He plus 2 ions, isn't it? He plus 2 ions and 2 electrons. 2 electrons will be removed from the helium atoms and it forms He2 plus ions. Here, the positively charged particles are He2 plus ions. These are called anode rays or positive ray particles. If you take some other gas, then the positive charged particles will be some more different. But if you observe, the negative charged particles are common in all the cases. So, whatever the gas we have taken, the cathode ray particles are being same. These all cathode ray particles together called as electrons. But the positive ray particles are being different from different gases produced. Okay, out of these all, the smallest positive charged particle is called proton. That is, the positive charged particle produced from hydrogen atoms are said to be protons. We cannot say all the positive rays are protons because they might be composed of so many particles in them. The smallest particle out of these all positive rays is called proton, that is produced from hydrogen atoms. Okay, remember this difference. Next, properties of these anode rays or protons. Let us see what are the properties of these positive rays or anode rays. These rays consist of positive charged particles. This is proved by the property these particles are produced from anode side and moving towards the cathode side. They move through the perforated cathode and strikes on the screen at backside of this cathode and then making red colored scintillations. So they're moving from the anode side towards the negative electrode. This proves as they are positively charged particles. Okay. Another property is they travel in straight lines. So we have seen this property for cathode rays also. How it is proved? They cast a shadow of the object placed in their path. So in the path of these anode rays, if an object is placed, its a shadow is created. They are casting certain shadows. If the object is moved up and down, the shadow is also moving parallel to that object. So this proves that these anode rays are moving in the straight lines. just like the cathode rays. Okay. Another property is they produce mechanical effects. Just like the cathode rays, these anode rays are also producing mechanical effects. This is proved by the experiment that a pedal wheel placed in their path starts rotating. So this we have seen in the case of properties of cathode rays also. If a light pedal wheel is placed in the path of these anode rays, then it starts rotating. This proves that these anode rays are also creating mechanical effects. They are producing mechanical effects. Because of that, this light pedal wheel kept in the path of these anode rays starts rotating. Okay, they create mechanical effects. And these positive rays can penetrate through the thin metal foils. So these anode rays or positive rays can penetrate through the thin metal foils. Next, these anode rays are positively charged. The charge of these anode rays is proved by the activity that anode rays are deflected towards the negative electrode of the electric field. So when high voltage electric field is applied in the path of these anode rays, then they start deviating towards the negative electrode. So this proves as these anode rays are positively charged because of this positive charge only they are being attracted towards the negative electrode of the electric field applied in their path. Okay, this proves as these anode rays are positively charged. Okay, and they are deflected by the magnetic field also. Just like the cathode rays, these anode rays are also deflected with the magnetic field also. Just as cathode rays, but in the opposite direction to the cathode rays deflection. So here, anode rays are also being deflected in the presence of magnetic field, but in the opposite direction to that of cathode rays deflection. This shows that they are positively charged. That is, these anode rays carry positive charge. Since their deflection is very little, so actually a cathode rays are deflected much in the presence of electric field or magnetic field. But the deflection of these anode rays is somewhat little when compared to cathode rays deflection. This shows that they consist of a very heavy particles. So as the heaviness, the mass of particles increasing, the deflection decreases. The deflection created by this magnetic field or electric field is somewhat less for these anode rays compared to that of cathode rays. This shows that these positive ray particles are having heavy particles. Okay, not just like the cathode rays, they have heavy particles. That is why the deflection is being somewhat less. The nature of anode rays depends upon the gas taken in the discharge tube. Here it is one of the important point about anode rays, where these are differed from cathode rays. So the nature of cathode rays is independent of the gas taken in the discharge tube. That means whatever the gas you take in the discharge tube, on applying high voltage current, cathode rays are produced from all the gases. The properties of cathode rays produced from all the gases are being same. Those cathode rays are considered as electrons, isn't it? But the anode rays produced are being different for different gases taken in the discharge tube. That we say the nature of anode rays depends upon the gas taken in the discharge tube. That means different gases give different types of positive rays, which contain particles having different masses and different charges. For example, if we take hydrogen gas in the discharge tube, what are the positive rays produced in that case? H plus ions, isn't it? So by the removal of electron from each hydrogen, one H plus ion is produced. In this case, positive rays are H plus ions, which we also call as protons. But if we take helium gas in place of hydrogen in the discharge tube, then the positive rays produced will be He2 plus ions. by the removal of 2 electrons from it, isn't it? So by the removal of 2 electrons, they form He2 plus ion. These are positive rays in this case of helium. So the properties of these He2 plus ions are entirely different from H plus ions. It has 1 unit mass, it has 4 units mass. It has 1 unit positive charge, it has 2 units positive charge. They're having entirely different properties. In this way, the nature of anode rays produced depends upon the gas taken in the discharge tube. Okay, but in all the cases, cathode rays are being same, electrons only. There is no difference in those. Only in the case of anode rays, the nature is dependent upon the gas taken in the discharge tube. Right? Therefore, the E by M ratio is not constant for positive rays. Okay, the E by M ratio means charge to mass ratio is not constant for these positive ray particles obtained from these different gases. So E by M ratio for this gas will be different from the E by M ratio of this positive rays. It depends upon the gas taken in the discharge tube. Okay, that's the only difference from the cathode rays. Almost all the remaining properties are being same, just like the cathode rays, but in the opposite directions. Only this is different. The nature of cathode rays does not depend upon the gas taken in the discharge tube, but for anode rays, it is dependent on the gas taken. Okay. Now the charge of proton. Proton here representing the smallest particle of these anode rays, that is H plus ion. The charge on a proton is equal to that of an electron, but it is the opposite charge, that is the positive charge. We know the charge of electron is negative unit, whereas the charge of proton is positive charge. The charge of a proton is equal to 1.602 into 10 to the power of minus 19 coulombs, which is quantitatively equal to the charge of electron. But here for proton it is positive charge. We know for electron it is negative charge. In electrostatic units, its quantity is equal to 4.8 into 10 to the power of minus 10 electrostatic units. These are charge of electron. In coulombs, it is 1.602 into 10 to the power of minus 19 coulombs. The charge of proton is the smallest positive charge carried by any particle. It is the smallest charge carried by any kind of particle. Thus, the charge carried by a proton is taken to be 1 unit positive charge or plus 1, whereas the charge of electron is taken as a 1 unit negative charge or minus 1. So both are having same quantity of charge but opposite in charges. Charge of electron is taken as 1 unit negative, whereas the charge of proton is taken as 1 unit positive. Okay. Next, mass of proton. The mass of proton is found to be identical to that of hydrogen atom, which is 1 atomic mass unit nearly. Okay, the mass of proton is equal to mass of hydrogen atom, which is nearly equal to 1 atomic mass unit. This is the smallest standard of mass, which is equal to 1.672 into 10 to the power of minus 24 grams. So the mass of proton in grams is taken as 1.672 into 10 to the power of minus 24 grams, or 1.672 into 10 to the power of minus 27 kgs. That also we can take. But in atomic mass units, to say accurately, it is equal to 1.00727 atomic mass units. Okay, in AMUs it is equal to this. But in general, the mass of proton will be taken as 1, nearby to this, 1 AMU. But to say accurately, it is equal to 1.00727 atomic mass units. But general in the calculations it will be considered as 1 AMU. Okay. A proton is about 1837 times heavier than an electron. So if we take a balance, if we try to balance the mass of proton and electron, on one side if we take one proton, to make it balanced with the mass of electron, we have to take around 1837 electrons on the other side. So 1837 electrons mass will equal to the mass of one proton. That is why we told the mass of electron is negligible when compared to the mass of hydrogen or one proton. It is very less. We know its value in grams equal to 9.11 into 10 to the power of minus 28 grams. But when compared with the one proton's mass, it is very less. Mass of electron is 1 by 1837 times to that of one proton. That's why mass of electron is said to be negligible. Okay. Now, charge to mass ratio of anode rays, that we say simply as specific charge of anode rays, or E by M ratio also it is called. Unlike cathode rays, the E by M ratio of positive rays or anode rays depends upon the nature of the gas taking the discharge tube. Already we told that the E by M ratio of sorry, the E by M ratio of anode rays is a constant for all the gases whatever you take inside the discharge tube, because they are being same. The cathode rays are being same whatever the gas we take inside. So their E by M ratio is fixed and they have highest also among all the particles. But for by coming to anode rays, these anode rays are being different for different gases. So they are having different properties like charge and mass. So the E by M ratio also is not being constant for these anode rays. The E by M ratio or specific charge depends upon the nature of the gas taken in the discharge tube. So the charge to mass ratio of particles in the anode rays is considerably smaller than that of electrons. As we told, the E by M ratio of electrons is highest because E by M ratio means charge to mass ratio. We know the mass of electrons is very small, almost it is negligible. So the denominator values as being very small, the overall value for cathode rays or electrons will be highest. So it is considerably greater than that of anode rays E by M ratios. Okay, E by M ratio for protons is smaller than that of electron. But here E by M ratio of anode rays is not fixed. All kinds of one of the kinds is proton. There are different kinds of anode rays. One of those and the smallest one is proton, that is H plus ion. Okay. So for different anode rays, different charges will be there, different masses also will be there, and hence their E by M ratio will be different from others. Changes from gas to gas taking the discharge tube. It is not fixed. But for cathode rays, the E by M ratio is fixed because whatever the gas we are taking inside the discharge tube, the produced cathode rays are being similar. Those cathode rays we are calling as electrons. Their charge and mass are being fixed. So we can say their E by M ratio is constant. But for anode rays, it is being different here. Okay. Now let us see a solved example based upon these properties of anode rays. See the question here. What is the total mass of 4 protons? If we know the mass of 1 proton, then we can calculate the mass of 4 protons. It is a solution. Mass of 1 proton we know as it is 1.67 into 10 to the power of minus 24 grams, or else 1.00727 into 10 to the power of AMUs, 1.007 AMUs. In grams, it is taken as 1.67 into 10 to the power of minus 24 grams. This is the mass of one proton. Now they are asking to calculate the mass of 4 protons. So it will be equal to 4 into the mass of proton. We get it as 6.68 into 10 to the power of minus 24 grams. This is the mass of 4 protons. Okay. This is about the discovery and properties of these anode rays and protons. Remember, all cathode rays are electrons, but all anode rays are not protons. Anode rays are being different from gas to gas. Out of these all, the smallest anode ray particle is considered as proton, that is H plus ion. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.